along. So factoring is basically the reverse of the distributive property as of right now. That's as far as we've gotten. So what if we had a negative or a -1 out in front of a set of parentheses is what this next one was. Well, we found out when you have a negative or a -1 out in front of a set of parentheses, it means that you're going to multiply that negative or -1 to everything that's on the inside. And what it does is it will change a negative times the negative will become a positive 2x squared. Then the negative times the positive 3 will become a negative 3x. Then the negative times the negative will turn into a positive 7. What it does is it switches the signs. So the question then becomes, how do I know what to do, and how do I know when to do this in reverse when I'm factoring? And it's actually going to be super simple. We are only going to factor out a negative or a -1 when we have a negative in our first term. So we will factor out a negative sign or a -1 when, and this is only when the first term is negative. It's the only time. But we do need to watch out for this because it will pop up here and there throughout the chapter. So let's take a look at an example. So in this first one, we have -4x squared y squared plus 6xy squared. And what we're going to do is we're going to find our GCF normally. However, because our first term here is negative, whatever our GCF is going to have a negative on it. So I'm going to say that this is going to be equal to, and our GCF always comes first. It'll be negative because our first term here is negative. Now just go through your numbers normally. 4 and 6 are both divisible by 2, so we can factor out a 2. We have an x squared and an x, so both terms have at least one x, so I can factor out an x. We have a y squared and a y squared, so both pieces have at least 2 y's, so I can factor out a y squared. Then, just like before, I need to pull out each and every piece out of both pieces, so I'm going to start out with the -2 first. So, dividing or factoring out a -2 first from a -4 will turn it back into a positive 2. Pulling out 1x will turn my x squared into just 1x. Pulling out a y squared means that those will both be gone, so we pulled out 1x and 2 y's. Plus, now the -2 goes into positive 6 as, be careful, as positive 6 as actually negative, as negative 3. We pulled out 1x, so it's gone. We pulled out 2 y's, so that'll be gone. So, what do we notice? Factoring out this negative switches the signs. The first term that was negative became positive. The second term that was positive became negative. That's exactly what we expect. Notice our leftovers don't have anything in common, so I did get my greatest common factor, and I am done. Let's take a look at B. In B, we have a -10x to the 4th, y to the 3rd, z squared plus 8x cubed y squared z minus 20x squared y. And let's start out with realizing that first term has a negative, so our GCF, when we factor it out, will also have a negative. Then we need to look at all three sets of leading coefficients, the 8, the 10, and the 20, which are all divisible by 2, so I can factor out a 2. Then let's look at our x's, our x to the 4th, x to the 3rd, and x squared. Each piece has at least 2 x's, so I can pull out or factor out 2 x's from each piece. Then I've got a y cubed, a y squared, and a y. So each piece has at least one y, so I can also pull out a y. However, let's look at the z's. I've got a z squared, a z, and no z. So I can't pull out any z's because that last piece doesn't have any. So our leftovers will go in their own set of parentheses, but I'm pulling out this -2, x squared, and y out of each of the three pieces. So the first thing, dividing out the -2 from the -10 will actually turn that into a +5. Pulling out 2 out of the 4 x's will still leave me with 2 x's, so an x squared. Pulling out 1 y will, instead of 3, now leave me with 2. But I still had the 2 z's. Z's did not get touched here. And then continuing along, let's see. -2 divided into +8 will give me a -4. Pulling out 2 x's, we had 3 will only leave me with 1. Pulling out 1 y, where I had 2, will only leave me with 1 y. And I didn't touch the z's, so I'll still have a z in that middle term. Keep on going. -2 goes into -20 as +10. We pulled out 2 x's, so they'll both be gone, and pulled out 1 y, so that will also be gone. So we'll just have the 10, and I can close off my parentheses. Again, I always do a quick double check to make sure I switched all my signs. Negative became positive, positive became negative, and negative became positive. Remember, factoring out a negative should switch all of your signs. Now with this next part, we're still going to be factoring out a GCF. It's just the GCF looks a little bit more complicated. So let's take a look at this first example. In this first example here, we've got an a plus b times x and an a plus b times y. So their common factor, what they have in common is that they both have a matching a plus b. So what do we do when we have a common factor? We pull it out in front. Notice I'm going to pull it out in front the exact way it looks, because that's what's matching, is the a plus b inside of parentheses. Then remember, our leftovers go inside of their own set of parentheses, and their leftovers are an x plus y. So I'll leave my leftovers as an x plus y. So that's it. That's my final answer, an a plus b times an x plus y. So this is still considered factoring out the GCF, the greatest common factor, because you're pulling out something that matches the a plus b with parentheses. It just looks a little funny. So we're going to continue by doing the same thing throughout this section. We're still just factoring out the greatest common factor. So let's take a look at this next example. In this next example, we've got a 5 times our x minus y minus r times another x minus y. So what do they have that matches their greatest common factor? Well, they have a matching x minus y with parentheses around it. So we can pull that out in front. So we're pulling out an x minus y with parentheses around it out of both pieces. Then the question is, what's going to be left over after we pull out the x minus y from both pieces? They'll go inside of their own set of parentheses. Well, what'll be left over, though, inside of those parentheses is the 5 minus r. But that's it. We are done. That's our final answer and how exactly we would type it into MyMathLab. I will say, be careful with MyMathLab. If you have a capital R, yes, you have to type it in as a capital R. If you actually type it in as a lowercase r, it will mark your problem wrong, so just be very careful when you're keying things in. Let's take a look at B. In B, we've got x times a plus 2b plus y times a plus 2b. And again, we're factoring, so we're looking for what do they have in common once again. Well, these two pieces have in common an a plus 2b. So just like before, they match up. We're going to pull them out as our common factor exactly as they appear. They appear, though, as in a plus 2b with parentheses around them. So when we pull them out, that'll be the same. The question is what's going to be left over to go inside of another set of parentheses. Well, our leftovers will be the x plus y. And again, leftovers go inside of their own set of parentheses, but we are done. This idea of pulling out this greatest common factor that matches, that looks a little complicated, we're going to use this a lot to make our lives a lot easier with factoring. Okay, let's try one more. So this one's a little bit more complicated, not much. We've got a 3x times c minus 3d plus 6y times c minus 3d. Well, right off the bat, now that we're getting used to this, it should pop out kind of right at you that there is a matching c minus 3d with parentheses around it. So yes, we can start out by pulling out a c minus 3d parentheses and all. But we can't ignore that there's also a common factor of, we've got numbers, a 3 and 6. Well, 3 and 6 are both divisible by 3. Notice they aren't in any set kind of parentheses, so when I pull it out of both, they're not going to be in any kind of parentheses. So I'm pulling out a common factor of 3. There's no parentheses, so when I pull it out, no parentheses. Then my leftovers, though, always do get their own set of parentheses. What's left over is an x plus, well, we only pulled out a 3 from the 6, so I still have a 2, and I still have my y. But that's it. So this time I didn't just pull out a c minus 3d like I have before, but I also pulled out a common factor of 3. But I am done, and that is my final answer. And I will say something, I tend to color code things a lot, and a lot of my students get used to that. On a test, feel free to, even on your scratch paper, use color-coded, whether or not use highlighters, markers. You don't have to, but if it makes your life easier, feel free. Line up a whole set of markers or highlighters or whatever makes your life easier. Let's take a look at D here. In D, we have a 9a squared b squared 3x minus 2y plus 6ab times 3x minus 2y. So let's see what they have in common. Let's go piece by piece. First of all, we'll start out with the 9 and the 6. The 9 and 6 are both divisible by 3, so I can pull out a 3. Notice there's no parentheses, so when I pull it out, no parentheses as well. Then I've got an a squared and an a, so they both have at least one a, so I can pull out an a. Let's look at our b's. I've got a b squared and a b, so they both have at least one b, so I can pull out a b as well. And the big part is they also have a huge matching piece of 3x minus 2y with parentheses around it, so I can also pull out that. Because they match with parentheses around it, that's what's going to get pulled out, the 3x minus 2y, exactly the way it matches, parentheses and all. And so I'm pulling out a 3, an a, a b, and this 3x minus 2y, and then whatever's left over will be inside of its own set of parentheses. So pulling out the 3 first from the 9 will leave me with another 3, because 3 goes into 9 3 times. Pulling out the a, well, I had 2, will leave me with still an a. Pulling out the b, I had 2, so I'll still have 1. And pulling out the 3x minus 2y means it'll be gone. Then the 3 out of the 6 will leave me with a positive 2. Pulling out the a means it'll be gone. Pulling out the b means it'll be gone. And pulling out the 3x minus 2y means it'll be gone, so I just have that 2. So our final answer looks a little bit bizarre, but I pulled out a 3, an a, a b, and a 3x minus 2y, parentheses around it. And I was left with the 3ab plus 2, and again, those get their own set of parentheses, but I am done. The next thing that we're